Hello, everyone. So we are in lesson 5, and I want to go over some of these problems in the book. Now, I want to start from problem 13. And in problem 13, we have a quadratic function, negative x squared plus 2x plus 5. Now, we want to find the vertex, we want to find the y-intercept, we want to find the horizontal intercept, and we want to plot and label all of these points on the graph. It says round your values to two decimal places. So we know what this means. Now, the thing that I've been talking about every time is that read the whole problem. If you read the whole problem, you would understand what you are supposed to find and all that you're supposed to do. So with this one, first of all, let's find the vertex. We know from previous class and previous videos that when you find a vertex, the x value of the vertex is going to give us the axis of symmetry. So x equals whatever we get for the x value of the vertex. So let's find the vertex. We know that the vertex is always going to be the x and y. The x is going to be negative b over 2a. And then whatever we get for our x, we put it in to the function to get our y. So from the function, f of x equals negative x squared plus 2x plus 5. Our a, if we compare this to the general form, ax squared plus 2x plus 5, our a is going to be negative 1, our b is going to be 2, our c is going to be 5. Now, to find the x value of the vertex, we know that x should be equal to negative b over 2a. So x equals, our b is 2, so we have negative 2 on top, and then we have 2 times negative 1 for a. So this should give us negative 2 over negative 2. And this should give us positive 1, right? 2 will cancel 2, so we have 1 over 1, which is 1. So x is 1. Now we are going to get the y, we're going to have f of 1, right? So we put that in the function. So we have minus 1 squared plus 2 times 1 plus 5. That is from the function. So this should give us 1 squared is 1. Remember, the negative is outside, so you attach the negative, plus 2 plus 5. Now going from left to right, negative 1 plus 2 is positive 1. Positive 1 plus 5 is positive 6. So what would our vertex be when x is positive 1, y is positive 6? So the x value is 1. So our equation of axis of symmetry is going to be x equals 1. All right. Now, what about our y-intercept? Remember, our y-intercept is always x equals 0, y equals c. And what is c from our function? C equals 5. So we have 0, 5. Now, what about our horizontal intercept? Again, we've gone over how to find that from the graph, right? We've done that. So I'm going to share my calculator and then go over that real quick. All right. So I go to y equals I'm going to erase what I have for y1, and then I'm going to put in the function. Remember, it's negative x squared plus 2x plus 5. Now we know from what we've done previously that for x-intercept, really you have negative x squared plus 2x plus 5 equals 0, right? Because y is 0 and f of x is y. So this is going to be your y1 and this is going to be your y2. So I'm going to put 0 in for y2, so I go down and then I put in 0. Now I'm going to go check my window real quick. So I've got a standard window, so I go to graph and see what I have. Now we did know that this is going to open down. Why? Because a is negative. We knew that. It's going to go down because a is negative. All right? So this is what I have for my graph. But I know that this point here is going to be my y-intercept. This and then that. I mean my x-intercept, sorry. My x-intercept. But how do I find it? So you go second, calculate, and second trace. You hit second and then trace. It's got calculate on top, so it's telling you that you want to calculate. Then you scroll down to 5, or you hit on 5. Now you see that the cursor is here. Now, looking at where the cursor is, I think it's close to this x-intercept. But I'm going to move it more closer to it so that the calculator knows. It shouldn't be on it. It should be close to it. That's fine. And then now I hit enter, enter, enter. So you see that it says y equals 0. When y equals 0, our x is negative 1.44949, which to 2 decimal places is going to be when x is negative 1.45, our y is 0. So that is our first one for x-intercept. Now what about the second one? Again, we go second, trace, and then you choose 5. Now look at where the cursor is. I'm going to move it closer to my next x-intercept. Then I hit enter, enter, enter. So the next one says when x is, again, 2 decimal places, 3.45, y is 0. Now if you look at where the cursor is, now we knew that we had a standard window, so which means that this is 1, 2, 3. So we are not surprised that we are getting 3.45, right? It's kind of in the middle of 3 and 4. And then here we have negative 1 and then negative 2. It's also in the middle of negative 1 and so even though looking at it, you're not going to get the exacts, the calculator can give you the exact. So we have our x-intercepts. All right. Let's go back to the workbook. So we have our x-intercept and then we put the values in. All right. Now let's continue and then talk about quadratic equations. Now this time around, we are looking at an equation, right? So there should be an equal sign in it. We talked about this previously. So a quadratic equation has the general form ax squared plus bx plus c equals 0. Remember that a should not be equal to 0. We've talked about this previously. Now, to solve this quadratic equation, that is, you are solving for x, right? Because a, b, c are going to be numbers, are going to be real numbers. So to solve this quadratic equation, you're going to have to solve for your x's. Now, solving for these x's, So the x's are going to be our solutions, and we are saying that the quadratic equation should have real number solutions. Now, calculating for your x's, remember from what we've done so far, it's like calculating for what? Your x-intercept, really. Calculating for your x-intercept. Because y is 0, right? We just talked about that. Y is 0. Now, sometimes you might have a situation where your graph is not going to cut the x-axis like that. Okay? So we say that it doesn't have real number solution, but it has two complex number solutions, which we'll talk about later. Two complex number solutions, because the parabola does not touch or cross the x-axis. All right? And sometimes you might also have one real number solution. So your x is going to be just one number. That means that the graph cuts 1 point for this one. It cuts 1 point on the x-axis. In other words, you have just one horizontal intercept. So your x would only have one solution. And then you have the two unique real number solutions, which is going to be this one here. Okay? All right. So we have three cases, basically. All right. Now let's look at some examples. This is a media example, so I'm not worrying so much about it. Please watch the video because you have the video on the website, My Open Math, okay? So you're finding your x's, you're finding the solutions. Okay, so it says use proper notation to write the solutions and the horizontal intercept of this parabola. Now, in problem 15, this is a U-try problem. So let's look at that real quick. It says use your graphing calculator to help you determine the number and type of solutions to each of the quadratic equations below. All right. Begin by putting the equations into general form. Draw an accurate sketch of the parabola in an appropriate viewing window. And then label the vertex, the y-intercepts, and then any horizontal intercepts, okay? If your solutions are real number solutions, use the graphing intersect method to find them. Then use proper notations to write the solutions and the horizontal intercept of the parabola. All right, so let's take the first one. Now I'm going to go to my calculator because I need that, right? So let's see what we have. I'm going to change the screen to the calculator screen. All right. So what do we have for our function? We have where is it? We have negative x squared minus 6 minus 9 equals 0. So let's go to y equals. So we have negative x squared, negative x squared minus 6x minus 9. Now, my y2 is going to stay 0, right? Now, in the workbook, it says you have to label or show what window you use. So I have, for now, I have a standard window. But let's go check out the graph. Okay, this is what I have for my graph. So you could see that this is going to have one real number solution because it's cutting the x-axis at one point. Now, what is that point? You might as well, here you should see it, right? Because this is a standard or a standard window. So -1, -2, -3. So you should see that. So x is here, it's -3 when y is 0. But if you want to calculate for that, you do second calc 5, and then you hit enter. Yep. And then it gives you that -3.000001. But -3 is fine, right? And that's it. Because you only have one real number solution. So when you come back to your workbook, now look at the vertex. The vertex is the same as the horizontal intercept, right? It's the same. Because that is the highest point on the graph. And then what about our y-intercept? It's right here. And that you could also find that from your equation, right? Because this is -9. And that is c, our constant in the equation, right? C. So you have that. So when x is 0, y is -9. So when drawing this, you could label that 0, -9, and then -3, 0 for the x-intercept. And then we go back to the workbook. So let's go back to our workbook. Let's go back to it. And then we're going to share or change this. All right. So you have to sketch and label the graph. And then now your x minimum is going to be -10 because I use the standard window. And +10, -10, +10. Now, how many real number solutions? 1. What was the real number solution? What was the solution? That is the x. What was the x-intercept? -3, and then 0. Right? And that's it. All right, let's try the second one, b. Now, for b, we have 3x² plus 5x plus 20 equals 0. So we go back to the graph, or go back to the calculator, I mean. And then we are going to do this all over again. So we have y equals, so I go to y equals, and then I have to erase all this. What was the function again? It's 3x². So 3x² squared plus 5x plus 20 equals 0. So my y2 is going to be my 0. Now, I have a standard window. Let's see what I get. I know I have a standard window from last time. Let's see what I have. So where is my graph? It's hidden somewhere. So it tells me that I have a problem. Now, if you look at the equation, look at what we have here. We have 20 here. So that tells us that, oh, our y-intercept really is going to be 0, 20. So I have to change my window. I have to change my window, especially the y values, because my y-intercept is 20. So if I go to my window, let's keep the x as it is. And then what about the y? Let's do 25. And let's go to graph again. You see that? So it's hidden, it was hidden on top. So I might as well change the window again. and then go to y maximum, the positive should be 30, because that's where this thing is hidden. Oops, not this. Or perhaps I could change this to be a -5, the minimum, and then change this to be 30 or 35. Let's do 35. Yep, you see that? Now, what is happening here? The graph does not cut the x-axis. So what do I say? I say that there is no real number solution for this. No real number solution. Okay? No real number solution for this. So how do I put this in? Let's go back to the workbook and check it out. So I'm going to share again. So what are we going to say? We are going to say that the x minimum, I did -10, x maximum +10. This I did -5 and then 35, which is fine. And then make sure that when you draw your graph, you set it up in the same way, okay? Or perhaps this should come down a little bit because this was -5, so, okay? So the number of solutions is 0, right? It's 0. And then what else do I have? So what about the real solutions? It's none. And then the horizontal intercept for that, it's none. And that's it. So none, none, and that's it. Okay? All right. Now the last one, I'm going to leave it for you to complete it. But if you need the answers to that, for the window, it depends on you, right? It depends on you and what you do for the window. So for the real number solutions, there are 2 solutions. And then what are the solutions? X equals -3.5 or x equals 1. So the horizontal intercept is -3.5, oops, 3.5, 0, or 1 and 0. All right, okay. Now let's keep going to 5.2. Now here we want to really look at how to solve quadratic equations graphically. And we just talked about it, right? We just did the same thing, solving quadratic equations, but we were looking at finding the real number solutions and also finding the horizontal intercept. Now we really want to talk about finding solving quadratic equations. So let's say that we're trying to forget about horizontal intercept for now, solving quadratic equations. Now here you have the steps to do that. So you go to y equals, you put in that, and you whatever you have for d, from here you put y2 to be equal to d. Okay, and then you graph the 2 equations. Which 2 equations? These 2 equations. When you go to graph, it should give that to you. Adjust the window if it's possible. Okay, and then go back to second cal intersect to find the value. So it's kind of like the same as solving for the y-intercept, only that the y-intercept, y was equal to 0, right? I mean, yeah, y was equal to 0. So we set y2 to be equal to 0, always, always, always. We did that. All right. Now, if you look at this example, problem 16, we have y1 here, and then we have y2 here. Okay, so you go to the calculator, y1 and then y2. y2 equals -5. And then you find the intersection point. you find the intersection point. Now you would see that from here, this is the graph you're going to get. You're going to have. So this is what you're going to have. This line here, this line, is going to be y equals -5. And these points are going to be the intersection points. What is x? -1. What is x? 0.33. So for this equation, x equals -1 or x equals -0.33. It has to be negative 0.33. Okay? And you're done with solving the equation. That's it. You're done. Okay? So you can try this on a calculator, but let's look at problem 17. Problem 17. This is a media example, so there is a video on it. So I might as well skip it. Please watch the video and then find the solutions for x. Now let's quickly look at B. Let's quickly look at B. Okay, let's look at problem 18. Now with problem 18, what do we have? Problem 18. So this is what we have. Solve 2x squared minus 5 equals 6. 2x squared minus 5 equals 6. That is what we are solving. Problem 18. Now again, we are using the calculator, right? We are using the calculator, so we want to go and then go to the calculator. So I'm going to share that very soon. Let's see. All right. So, I'm going to share the calculator. All right. So, we go to y equals, and then we're going to erase this. So what did we have for our function? We have 2x squared, x squared minus 5. Then our y2 is going to be 6. Okay, y2 is going to be 6. And then let's check our window. Let's do a standard window for now, zoom 6. Wow, look at what I have. So remember that our y2 is y equals 6. And here, y is 6, right? So we know that that is where the line is going to be. A horizontal line. Okay? Now, we have this. Now it's not going to be the x-axis anymore, right? Because we're trying to solve the equation. y2 is not equal to 0. If y2 is equal to 0, then it's going to be the x-axis. But y2 is equal to 6. So to know, I mean, here you might as well connect it and then see, you might connect it this way and then see, but it's not going to be exact. So let's try to find it. So second, calc 5. Now look at where the cursor is. I'm going to move it to the left side, close enough, yeah. Then hit enter, enter, enter. So what do I have when y2 is 6? When y2 is 6, my x is negative 2 decimal places is fine, 3, 5. What about the other one? Because there are two solutions, right? What about the other one? So let's go second calc again. 5. Then I'm going to move the cursor. Remember, it's a left and right. You don't do up or down, okay? And then hit enter, enter, enter. So I have x equals positive 2.35. So these are my two values that I needed or wanted. Now I did use a standard window. So when you go back, it says you have to sketch the graph. So I'll sketch the graph. And then going back to the workbook, and then make sure that I put in my window -10, +10, -10, +10. I sketch the graph. And what are my solutions? X equals -2.35 or X equals 2.35. That's it. All right. Now let's look at B. Let's look at B as well. Let's look at B. Now for the sketching of the graph, please try to do it, okay? All right. Now let's look at B. Now for B, we have solved x squared plus 9x minus 18 equals 32. Now looking at this, I have some big numbers, 18, 32 here. Okay, if I'm trying to find my window or get my window, I know my y should be a little bigger, right? I know that. So going back to the calculator, I'm going to switch again. What I'm thinking about now is my window. So let's see what we're going to have. So share screen, change that, go to the calculator. I'm going to go y equals again. Then I'm going to erase and then put in x squared plus 9x minus 18. And then I have 32 here. So let's go to graph. You see that? So what is the problem with this graph? This part, you could see that the graph goes down like that, but it's hidden. So we have to increase the negative y. And then here, this part I would say it's fine, the positive x part. But here we have to increase this a little bit because the graph is hidden somewhere here. Some part of the graph is hidden. And then, yeah, if you want to, you would increase the positive y as well. So I'll go back to my window. So my negative x, I'm going to do -20. My maximum x is okay. I could reduce it, but I'm going to stay at 10. Now my negative y or my minimum y, I'm going to do, let's do negative maybe 40. Yeah, I'm going to go big on it. And then for the maximum, I'm going to do 42. Then go back to graph. Oh yeah. So now it's better. It's better. Okay. So you're supposed to sketch this. So sketch the two equations. This is y equals 32, right? And this is our y1, which is what? X squared plus 9x minus 18. Now, how do I get my solutions, or how do I solve for my x? Second, calc, 5. And I'm going to move it closer to the first one on my left. I think they should be fine. Enter, enter, enter. It's right on it, right? What is x? -12. So x equals -12.88. Now, what about the second one? There are two solutions. So what about the second one? Second, 5. And I'm going to move this to the other side. and then hit enter, enter, enter. And what do I have? X equals 3, 2 decimal places is fine. Those are my solutions. Now check your window again. Make sure that you remember, you copy and put it in there, right? Your window should not be the same as my window. It should be a window that makes sense, and then draw the graph based on what you got for your window. Okay, draw the graph based on what you got for your window. All right. So let's go back to the workbook. Okay. So you make sure that you put in your window. X minimum I did, I think, -20, and then X maximum I did +10. Here, Y minimum I did -40, Y maximum I did 40. You put your solutions there, and that's it. All right. Now we want to look at some applications of quadratic functions. Applications of quadratic functions. Now, usually for quadratic applications, you are looking at questions like launching objects into the skies, like arrows, like golf ball, baseball, rockets, okay, or throwing things off buildings, okay? And that is what I have up here, talking about applications. Now, there are some important things you have to know for you to solve these application problems and then get the solutions right. How to solve quadratic application problems. Draw a graph, an accurate graph of the function, using the first quadrant values only. Now, this is very important. Why should we use the first quadrant only? Because when you're talking about application problems, let's say you have X to be time, and then your Y to be, let's say, height. Now, you know that you are never going to get a negative time, right? -2 seconds. It's impossible. So all your X values are going to be positive, which will be the first quadrant, which will be this part, right? The positive X axis. And then height, you are never going to get negative height. So you're always going to have that as well. So Y is positive, X is positive. And this is the first quadrant, Q1. So you don't need this part. You don't need this part. All you need is the first quadrant, and that's it. All right. Identify, plot, and label the y-intercept or the vertical intercept. Identify, plot, and label your vertex. What about the horizontal intercept? Try to get that as well. Okay. And then now look at the specific questions you're going to have. Now, because this is an application problem, you're always going to have the problem set up with applications or set up practically. So if you're trying to find, let's say the question wants you to find the y-intercept or the vertical intercept. It's not going to say find the y-intercept. No, because this is a practical or application problem. So it's going to say how high was the object at time t equals 0. Now, at time t equals 0, x is 0. So you're finding how high, that is if y is the height. How high means that you are finding what? The y-intercept, the y value, right? Because t is 0 or x is 0. Or it says, what was the starting height of the object? Why are we using the starting height? Because starting height means that your t, your time is 0. So that is vertical intercept. So you have to know that it's trying to tell you to find the vertical intercept. Now, what about the vertex? What about the vertex? So you have questions like, how high was the object at its highest point? We know that the vertex is the highest point on the graph or the lowest point of the graph. So if it says the maximum height, you know you are looking at the vertex. How long did it take the object to get to its maximum height? The vertex. How long means you are looking at time, right? How long time, which is the x value of the vertex. How the maximum height, you are looking at the y value of the vertex. What is the practical range of this function? The practical range of this function, again, you are looking at from 0 because this is a practical problem. Remember, we are only looking at the positive y values. So 0 to the y value of the vertex, to the y value of the vertex. Now, what about the horizontal intercept? Remember, for the horizontal intercept, y is always 0. When did the object hit the ground? When is time, right? When the object hit the ground, the height is going to be, so if this is the ground, okay, this is my y, right? Height. This is time. When the object hit the ground, let's say the object hit the ground at this point, this is 5. So 5 seconds or 5 minutes. So here, y will be 0. Y will be 0. So when the object hits the ground, the height is 0. So that is y equals 0. What is the practical domain of this function? The domain of this function, that is the x part, it starts from 0 to 5, right? So you know that you will find the x-intercept. How long did it take the object to hit the ground? Again, you are looking at the horizontal intercept. How far was the object from the center? How far was the object from the center? Again, you are looking at the x-intercept. All right? Okay. You have this in your workbook, so you can go over that. Now, here we have a worked example. Now, first of all, it gives you the function. H of t equals negative 16t squared plus 80t plus 130. Where h of t is the height in feet. This models the height of an arrow shot into the sky as a function of time in seconds. So before looking at even the specific questions it's going to ask you, get your y-intercept, your vertex, your horizontal intercept. Okay? All right. Now, what about your graph? Get your graph. Now, remember your minimum y, because we are looking at the first quadrant, your minimum y will be 0. Your minimum x will be 0. Right? But if you look at these values here, you know that your y-intercept is high, 130. So you're looking at some big values for the y. So the y should go maybe to 250 or 300. Okay? And then look at the vertex, the highest point on the graph, 230. So that tells you that my y value, this is the y value of the vertex, is going high, 230. That is the highest. So you could do 250. And then you go to the calculator and then you get your graph. So if I go to my calculator now, I'm going to share the screen again for the calculator. So I have to put in the function. So I go to y equals, I'm going to erase this. So I have, what was the function? Negative 16. So it says t, but we're going to do x squared plus 80 t, or x, plus 130. Okay? Then we are going to set up our y2 to be 0 because we are going to be looking at the y-intercept. Okay? Now, what about my window? Now, because I know what my vertex is, now remember here we are doing the first quadrant, so the minimum will be 0 because x is time, right? So the minimum, you don't get a negative time, so we know that. Okay? Now my x value for the vertex is 2.5, so I'm just going to leave this from 0 to 10. But for my y, I'm going to do 0 because we are dealing with the first quadrant. Then I'm going to do 250 for y. Now I go to graph. See what I have? And that's exactly what we have in the workbook, or similar to what we have in the workbook. That's what we have in the workbook. Okay. All right. So if you want to find the x-intercept, which is going to be here, we know the vertex is somewhere there, right? So let's see if we can calculate for the horizontal intercept. So second, out, 5, enter, enter, enter. Yes, so it gives us that when y is 0, x is 6.29. There's a horizontal intercept. So right here, you know that our domain or practical domain for our time will go from 0 to what? 6.29. So that is when the object or the arrow hits the ground, 6.29. And at this point, from the x-intercept, y is 0, right? 0 height. All right. So let's go back to the workbook. And then let's look at what we need. Okay. So going back to the workbook, let's go to the questions now. A says, after how many seconds does the arrow reach its highest point? After how many seconds does the arrow reach its highest point? Now, the highest point of the arrow is going to be from the graph, it's going to be here. And that is the vertex, right? Let me use it right. That is a vertex. But it says after how many seconds? So we are looking at the x, right? The time, which is 2.5. B, how high is the arrow at its highest point? How high is the arrow at its highest point? Again, the vertex. So it's 230 feet. 230 feet above the ground. 230 feet. Okay? You don't have to write the output value of the vertex or the y value of the vertex. No. You say it reaches its highest point after 2.5 seconds. The arrow is 230 feet above the ground at its highest point. C, after how many seconds does the arrow hit the ground? After how many seconds does the arrow hit the ground? After how many seconds does the arrow hit the ground? Now let's go to the graph here. It hits the ground at 6.29 seconds, right? That is the horizontal intercept. So you put it in there. What is the practical domain? We have it right here. It goes from 0 to 6.29. What is the practical range? Now the practical range is going to be the y. We know so this is the thing. We know that this is the starting point, right? Which is our y-intercept, 0, 130. But for the range or the set of y values, it's not going to be from 130 to 230. It's not going to be that. It's not going to be this. No. Because it keeps coming down to 0. So the range is going to be from 230 to 0. 230 to 0. I know it starts from 130 feet, but that's not the range. Okay, 130 is part of the values, but it's not. It shouldn't be the starting range. No, it shouldn't. So the range is going to be from 0 to 230 right here. And remember, 0 is part of the value. So you have h of t is greater or equal to 0, but less than or equal to 230. What does the vertical intercept or the y-intercept represent? Now we know that the y-intercept is here, 0, 130. What does it represent? It represents the height of the arrow at time t equals 0. The height of the arrow at time t equals 0. Or you could say that the arrow starts at 130 feet off the ground. So maybe the person is standing, maybe it's standing on top of a building or whatever. We don't know, but we say that it's 130 feet. It starts at 130 feet off the ground. Okay. All right. Now this is a media example, so please watch the video on problem 20. Watch the video on problem 20. It's a tunnel problem. Now let's look at problem 21. Let's look at problem 21. Now with problem 21, we have a toy rocket. It's shot straight up into the air. The function h of t equals negative 16t squared plus 128t plus 3 gives the height in feet, so y is height in feet, of a rocket after t seconds. Round to 2 decimal places as needed. Okay, so A, it says draw a complete diagram of this situation. Find and label the following: the vertex, the vertex, the x-intercept, the positive side, of course, because this is a practical problem, right? We need a positive side. We don't need a negative side if there is a negative side. And then the y-intercept. And then we're going to answer the questions. So let's begin. So from this function, we know that the y-intercept is always going to be 0 for x and then c. So the y-intercept is going to be our 3, right? It's going to be 3 from here. So we have 0, 3. Okay, which means that the rocket is shot 3 feet from off the ground. 3 feet off the ground. Okay, now what about the vertex? Now our vertex is going to be negative b times over 2a, which is for x, and then f of x, or f of whatever you get for x, you put it in. So let's start with x, negative b over 2a. Now from our function, our a is negative 16, our b is 128, our c is positive 3. So we're going to have negative 128 2 times negative 16. And what does that give us? Negative 128 over negative 32. And this is going to give us a positive number. We're going to have 4 for x. So if x is 4, then we're going to put that into the function to get our y. So our y, or f of 4, is going to be, from the function, we have negative 16, 4 squared, plus 128 times 4, plus 3. Okay, so this should give us, I'm going to change this to a black. The blue isn't coming out well. So negative 16, what is 4 squared? You have negative 16 times 16 plus 128 times 4 is going to give us 512 plus 3. So this should give us negative, this should equal to negative 256 plus 5112 plus 3. And this should give us 259. So for the vertex, when x is 4, y is 259. Which means that 4 seconds, after 4 seconds, the height of the arrow is 259. And that is going to be the highest point, or the highest height. Okay? All right. Now we have our vertex. Now, what about horizontal intercepts? Now we have to use the graph, the calculator, right? We have to use the calculator. So we have our vertex and we have our y-intercept. Okay. So for our x-intercept, we have to go to the calculator. So let me do that now. So we go to y equals, and then what was the function? Again, it's going to be negative 16. So t squared, so x squared, plus 128 x plus 3. Because we're solving for the intercept, y2 should be 0, right? Should be equal to 0. Now let's go to graph. Let's go to graph before I check my window. So we'll see that there is a problem here. Now let's go check out the window. So I did, this was from the previous problem. So 0 to 10, but I see that my y is tagged somewhere. So I'm going to do the positive y to be, let's do 350 or 300. And let's go check it out again. Oh yeah, it's better now. It's better, right? So if you look at the vertex, the highest point, it was 259. So you know that 250 wasn't going to work. You have to increase that to maybe 270 or 300 is fine. Okay. Now, to get a horizontal intercept, I could see this is going to be positive. If I count, because I know that this is in increment of 1. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, or maybe 8 point something. I'm not sure, but let's check. Second, out, 5, enter, enter, enter. So I have 8.023, so I do 2 decimal places. So x 8.02, y is 0. Now for the next one, again, we're going to do second. We want to see if it's going to be positive. If it's not positive, we don't need it, right? Because you don't have negative seconds or whatever, negative 2 seconds or negative something seconds, no. So 5, and then I'm going to move the cursor to that side. I just want to see what I'm going to get. I'm thinking it might be negative, but let's see. Maybe 0. Enter, enter, enter. So it took me back here. So it tells you that you're going to get a negative. You're going to get it. Oops. You're going to get a negative. Second, 5. I'm trying to see if I can move it close enough. I'm not going to see it because this is set up as the first quadrant, right? So you just have to let it go. So you have one horizontal intercept. You have just one horizontal intercept. Enter, enter, enter. You see that? Because that will not show because it's in the negative. So that's fine. So this is only positive. Okay? So that is our y-intercept. Okay. Now, with that, we're going to go back to the workbook and look at the questions we've got. So the first question, how long does it take the rocket to reach its maximum height? The maximum height again is the vertex. And what did we get for the vertex? We had for the vertex, I'm going to write it again. You have it in your workbook now, 4 seconds, right? 4 seconds, this is S. And then 259 feet. How long? So we are looking at time. So it took 4 seconds. Yeah, to reach, or it took 4 seconds for the arrow to reach maximum height. what was the maximum height of the rocket? That is this guy, the maximum height is 259 feet. It says write your answer in a complete sentence. So the maximum height was 259 feet. Question 3 or D. For D, how long does it take the rocket to hit the ground? How long does it take the rocket to hit the ground? Remember, the rocket was something like that, right? Oops, something like that. So we are looking at this part. That's where it hit the ground. And that was what? 8.02, the x-intercept. So if you do all those calculations, it makes it easy for you. You don't have to calculate anything, okay? So how long does it take, did it take it to hit the ground? It took 8.02 seconds to hit the ground. It took 8.02 seconds to hit the ground. It took 8.02 seconds for the rocket to hit the ground. What about E? Identify the vertical intercept. We already did, right? We already did. It was 0, 3. And what does it mean? It says write it as an ordered pair and interpret it mean. The vertical intercept represents the initial height or the starting height, right? The initial height or the starting height. The rocket was shot off 3 feet in the air. 3 feet in the air. Okay, 3 feet in the air. All right. What is the practical domain? Now I have my graph here. So the practical domain, remember we're going from 0 seconds. (8.02 seconds). What about the practical range? Remember it's going from here to the ground. So we have 0 feet, h of t. Okay, all right. So if you have questions about this, please reach out to me. Please reach out to me and I'm going to help you with that. So I'm going to pause this video here and then I'll make another video, okay, on the rest of lesson 5. Thank you.